Hello and welcome. In previous video, we have discussed the steps for converting CFG into CNF. In this video, we will explore few examples to convert context-free grammar into Chomsky normal form. Consider this is the grammar and we have to convert it into CNF. So first step for that was to simplify the grammar. And to simplify the grammar, we have already learned three steps. One is we have to remove the epsilon production, but there is no epsilon production into this grammar. Second was to remove the unit production, but again there is no unit production into this grammar. And third one was to remove the unreachable or useless symbols. So if we start from capital S, then we can go to A, but it is not possible to go to capital B. So production of B we have to remove because B is not reachable symbol. So now our final grammar after simplification would be S gives capital A, small small a, and capital S gives A, B. In second step, for every production of the form A gives alpha, if length of alpha, that means the length of right hand side of the production, if it is greater than or equal to 2, then every symbol in alpha must be variable, that is the capital letter. If we look at the first production, S gives capital A, B, A. So obviously the length of right hand side is greater than or equal to 2. So everything should be in variable form or it should be non-terminal. But we have only capital A as a non-terminal, small b and small a are terminal. So we have to replace those terminals by some non-terminal. So let us assume that for small b, we are writing a non-terminal called capital XB. And for small a, we are taking the another variable called XA. So XB and XA are actually one variable. They are not two. Okay, just a notation to understand that which variable we have used for small b and which variable we have used for small a. And similarly, in S gives double AB in second production, we already assume that XA we will replace by XA and B we are going to replace by XB. So second production can be written as XA, XA, XB. And we have assumed two things, A for XA and B for XB. So those productions we have to add into this. So now step 2 satisfies, this grammar satisfies step 2. In step 3, we have to convert it into CNF. To convert it into CNF, we know that there are two rules. One is all the productions must be of the form A gives capital B, capital C. On right hand side of any production, there must be exactly two variable. Or the production can be in form A gives small a. The right hand side of any production must have exactly one terminal. So first two productions are not in CNF form, last two are already in CNF form. So what we'll do is we will pick up the first production S gives A, XB, XA. As there are three variables, we have to introduce a new variable. So capital A will be as it is and we are introducing V1. And then V1 we will assume it as a XB, XA. So when we replace V1 in S, we will get the original production A, XB, XA. Similarly, for second production, we can write S gives XA and we can again assume another variable V2. And V2 would be now XA and XB. So when we replace V2 in S, we will get the original production back. And final last two productions are already in CNF format. So if we look at all the productions, they are satisfying the rules for CNF. They are either in form of A gives capital B, capital C, or they are in form of A gives small a. So this grammar is in Chomsky normal form. Consider another example. First step is we have to simplify the grammar. So we need to remove the epsilon production. So P is nullable, Q is nullable, and as P and Q nullable, S is also nullable because S derives P, Q, P. So everywhere we will replace P, Q and S by epsilon symbol. So S will become P, Q, P we have to keep as it is. Then we will replace one by one variable by the epsilon. So if we replace the last P by epsilon, we will get PQ. If we replace the first P by epsilon, we will get QP. If we replace Q by epsilon, we will get double P. If we replace Q and P as an epsilon, we will get P. And if we replace both the P's by epsilon, we will get Q. And if we replace P and Q both as an epsilon, all three variables, then that would be epsilon only. But at the end, we have to remove the epsilon production. So we are not writing here. In production of P, P gives 0, P will remain as it is. And then P is a nullable variable. So we have to replace that P by epsilon. So we are getting P gives 0. And we have to remove the epsilon production. So we are not going to add P gives epsilon. Similarly, for Q, we can write Q gives 1Q. And then we replace that capital Q by null, we will get just 1. Right? So right now we have eliminated the epsilon production. The second step is eliminate the unit production. Do we have any unit productions? For P and Q, we do not have any unit production. But for S, definitely we have, because we have production of the form S gives capital P, S gives capital Q. So there is an unnecessary chain. There is a transitivity, S to P and then P to 0P or 0. Fine. So what we'll do is those two productions we will replace by the original productions of P and Q. So first 5 productions of S will remain as it is. Then S gives P will be replaced by the productions of P, that is 0P and 0. And last production S gives capital Q will be replaced by original productions of capital Q, that is 1Q and 1. So this is the productions without unit production. We do not have any unit production in P and Q. So this grammar is after removing unit production. The next step is we have to check for the useless symbol. But from S we can go to P, from S we can go to Q. It means P and Q both are reachable from start state, and hence there is no useless symbol. So this is our simplified grammar, which is shown here in after eliminating the unit production. Next is we have to apply the CNF rules, that every production which is of the form A gives alpha, and if length of alpha is greater than or equal to 2, then all symbols of alpha must be capital letter. So if you look at the first production, S gives PQP, all are capital. S gives PQ, P and Q are capital. S gives QP, they are capital. S gives PP, they are capital. S gives 0P. So here there are two symbols, but 0 is a terminal. Capital P is non-terminal. So 0 we have to replace by some non-terminal. Then S gives 0. This is already in proper form because alpha is not greater than or equal to 2 for that. Length of alpha is not greater than or equal to 2. Then S gives 1Q. So 1 is a non-terminal that we need to convert it into terminal. So we can write the production S like this, where we have assumed that X0 represents 0 and X1 non-terminal represents 1. So X0 and X1 are not two symbols, but it is just one symbol. Mind it. Next production P gives 0P. So again 0 is non-terminal, so we have to replace it by X0. And Q gives 1Q, 1 is non-terminal, so we will replace that 1 by X1. And we have assumed that X0 to be 0 and X1 to be 1. So this is the grammar after step 2. And in step 3, we have to convert it into CNF. That means the right hand side of any production cannot be greater than of length 2. So first production S gives PQP. Here we have 3 variables. So we are just writing P and V1. And V1 we will assume as a QP. Rest of all the productions of S are of length 2 or 1. So that is okay. All the productions of P, Q, X0, X1, they are already in desired form. So we don't have to do any changes into that. So this is the final Chomsky normal form of given grammar. Let us discuss one more example. First step, we need to simplify the grammar. So to simplify the grammar, we have to follow 3 steps. First, we will remove the epsilon production. So X is nullable, Y is nullable, but S is not nullable because S is having 0 and 1 as well. So S cannot derive epsilon. So wherever there is a X or Y, we will replace it by epsilon. And from final set of production, we will remove all the epsilon productions. So S gives 0, 1, XY, we will write first as it is. Then when we replace Y by epsilon, we will be left with 0, 1X. If we replace X by epsilon, we will left with 0, 1Y. And if we replace X and Y both as an epsilon, then we will be left with 0, 1. For the production of X, X gives 1XY, we have to copy as it is. Then if we replace Y by epsilon, then we will have 1X. If we replace X by epsilon, we have 1Y. And if we replace X and Y both as a epsilon, then we will have just 1. And that X gives epsilon, we have to delete anyway. Similarly, for Y we can write down these many productions. Second step was to remove the unit production. Do we have any unit production for X? No. Do we have any unit production for S and X? No. Do we have any unit production for capital Y? Yes, there is one. Y derives X. So S and X would appear as it is. In Y, capital X should be replaced by all the productions of capital X. That is 1XY, 1X, 1Y and 1. And finally, we have to remove the useless symbols. From start state capital S, we can go to capital X, we can go to capital Y. It derives both. So there is no useless symbol into this grammar. Next, for every symbol in production of the form A gives alpha. If length of alpha is greater than or equal to 2, then we have to replace it by the variable. So if you look at the first production, S gives 0, 1, XY. So here length is greater than 2. So 0 and 1 should be replaced by some non-terminal symbol. So let us consider it as a C0, C1, because x and y are already there. So I'm not taking x0, xy, rather I'm taking it as a C0, C1. Fine. So all 0 and 1 will be replaced by C0, C1. Similarly, in x also 0 and 1 we have to replace by C0 or C1. In y also, and we have introduced four more productions. C0 gives 0, C1 gives 1, CA gives A, and there is only 3. CA gives A. Because there is only terminal A present in production capital Y, so that A is replaced by CA. So this is what the set of productions at the end of step 2. In step 3, we have to convert it into CNF. So if we have more than two symbols in right hand side of any production, then we have to create a dummy variable. So S gives C0 V1, because the first production is having 4 symbols. So C0 and V1 would be C1 XY. But if we initialize V1 by C1 XY, then there will be 3 symbols. So we have to break it down V1 as well. So V1 will be C1 and V2, and V2 will be XY. If you look at the second production, we have C0 C1X. So that we can write it as a C0 V3, and V3 we can have a C1X. Similarly, we will replace all possible non-terminals whenever length is greater than 3 by some Vi, and finally we will get the desired Chomsky normal form. So this is the desired normal form. You see, if we talk about production of Y, then Y gives Y capital X CA. So length is 3. So first we'll keep Y gives Y as it is, and we will assume some symbol V5 for XCA. So one production of V5 is introduced, and that we have attached with Y gives Y V5. So this is how we can introduce any number of such variables. There is no limit on name of variable. You can have any name. You can simply take A, B, C, D, you can take M, N, O, P, you can take V1, V2, V3, whatever variable we want to use, that you are free to use. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.